okay? And you go to, where is it? F. Quotation map. XY. And you go to nonlinear regression. Okay? And then in nonlinear regression, you have not entered. Okay, sorry. Let me just copy this into an XY system. As it doesn't know how to do it like this. File. And I want an XY with now just here. There we have it. And we now analyze the data, and here nonlinear regression. Okay? Okay? And now the easiest way of doing this is finding an equation that kinda looks like the one you want. Yeah? So you can go, in this case, to classic equations from prior versions of Prism, and you go to Boltzmann sigmoid. Yeah? Now, what's super nice about Prism is that you have a lot of tutorials and about a lot of information about what each equation means and so on. So you can always click around here and see what kind of information it provides. Okay? So, but I'm not going to do that. I'm going to do clone the selected equation. Okay? And I'm going to call it melting. Okay? And so, see what we have. We have bottom, top minus bottom. Okay? So why do we have that? Remember, because in the case of the traditional equation from what's his name? From Anfinsen, okay? He considered that you were going to go from 0% denatured to 100% denatured. But we don't have that. We just have a signal from the CD spectra, isn't it? So that means that our signal starts somewhere and it ends somewhere. It starts at something like minus 35 and ends at minus 16. So we cannot just go from 0 to 100. We have to go from where it starts to where it ends. Okay? So that's why we have this as our coefficient. Okay? And then in here, okay, we have 1 plus e to the power of v50 minus x divided by slope. Okay? So notice that basically this is very, very similar. It's just sort of turned around. What we want is to go back to our equation, which means that we're going to get Get it? Yes. Okay. Good. There we are.